Hello everybody, my name is Hello. Welcome back to this series where we're dealing with programming and design patterns in Python. In today's episode, we're going to be talking about the template pattern, which is actually a very simple pattern which you can use in your day-to-day coding also. So how template works. So something that you guys would have heard is a class is a template. A class is a blueprint to create an object. So what is a template of a class then? Well, let's say there are functions which are common. Okay, for example, let's say I have a vehicle, and that is a common class, right? And a vehicle always it starts, it runs, correct? But then uh, every vehicle, say car, something that inherits from a vehicle, it runs differently, correct? A bike runs differently, a bike starts differently, a car starts differently, maybe a cycle starts differently and runs differently. But all these cases, the run method and the start method is going to be something that's going to be common. So as someone who's writing code, what you will do is, well, I have a class called vehicle. Okay, and in this class, and this is going to be my base class, I'm going to convert this into Python so that we can start coding properly. So sorry, class vehicle. Okay, inside this class, I'm going to have the run method, correct? And well, this is just the vehicle, right? So I don't really want to do anything here, and I want to do maybe start. Okay, and this method does nothing over here for now, for example, right? And now I am going to create a car class. Okay, and I will inherit this from vehicle. Okay, and I'll say car starts. Car is starting. Car is starting. Okay, and similarly I'm going to have a bike class which inherits again from vehicle, and I will do something like start again. I'll just print bike is starting, and also we have the run method, right? So maybe something like bike is running with 2 wheels, something like that, right? Now let's say this is my example, this is my parent class, this is my children class, something that you've already seen as an example when you're dealing with object oriented programming, for example. Now the problem with this would be, let's say I'm creating an instance of a car, okay, and I'm creating an instance of a bike. Now what I'm going to do, I'm going to do the cars start function, cars run function, bikes start function, and similarly I'll do the bikes run function also. Now the problem with this is, okay, car should take car dot start take 0. Oh right, I have to give self in all of these, sorry. So I'll just give the self, and then self. Okay, I'll run this. You can see that the car is starting, the bike is starting, and the bike is running. When I do car dot run, nothing happens because I've not really defined the function run here. So it infers to its parent class, and there it just says pass. Now the problem with this is, when I try to write this vehicle, this was meant to be a skeleton, this was meant to be a template that other classes inheriting this should follow, which means apart from me just inheriting functionalities, some functionalities are supposed to be overwritten, because these methods such as run and start differ for all of these subclasses. So in this case, this will be my base class. Okay, now the problem with my base class is, you have a method called run and this simply says pass, right? And whether I choose to inherit or not is an option in this case, right? So in car, I'm not inheriting that. Therefore, it's referring to the parent class, and that is something that's not implemented. Therefore, this code is actually wrong. What I should have done is actually implemented this run method here, but I have not done. The code doesn't give me any problem. That becomes a problem because let's say I'm defining something like this. It is up to the user whether they want to implement that or not. That becomes a problem because if people forget it, these issues come where I'm not able to really call this functionality and it doesn't throw an error also. I don't know what the problem is, and that is where this template tries to solve this. Okay, Now, I am going to rewrite the same code as a template. Then we'll also deal with another scenario. But before that, I'd want to introduce you to something called as an abstract class. Okay, and this abstract class is actually really interesting and something that you will be using throughout your development journey. This is because an abstract class is a base class where we can actually force the user to implement these methods, so that in cases like these where we don't implement that method, you can actually go ahead and give an error. Okay, so how do you do this abstract class? Well, you have to do one import actually. So from abc, and abc stands for abstract base class. Okay, we will import abc. Again, this is a class and this is the module from where we're importing. So this will be abc abstract base class, and we need to implement something called as an abstract method, and this is what we'll use to tag these things as methods that need to be implemented. Now again, I'm going to go ahead and copy the same class here, except now I will inherit this from abc, and when I inherit this from abc, I'm allowed to use these decorators such as abstract methods. Abstract method. Okay, this is the decorator that we'll be using. If you guys aren't sure about what decorators are, we have a video on that also. I recommend you check that out, and then you can come back always, but that's not really required. So what I'll do is, in cases like these, right, I will add something called as an abstract method. Okay, and again I'll add this to this start over here. Okay, and now what happens is I'll copy the rest of the code to the same, and I will show you. What do you think will happen if I run this? Okay, boom, I get an error. It says can't instantiate abstract class car without the abstract method run. So it's telling me this is you are inheriting from an abstract class and you have not implemented the run method. Therefore, I will not go ahead and make compile this class properly or allow you to create objects. This is not a valid class because it has not implemented all the methods in the abstract base class that it refers to. Okay, so this is an abstract class. Now I'm going to go ahead and implement this method now, this run method, and I'll print something like car is running now with 4 wheels. Okay, and now what do you think will happen? Well, all my methods are implemented properly. I will do the run. You can see that all 4 are doing properly, and now I actually have a solid implementation of the run. Okay, now let's come back to this and let's add a bit more detail about why we need to have an abstract class. Now, something that I told you, if you do this abstract method decorator, right, you just need to define the function. You don't have to do anything here actually. So I'm going to just do 3 dots, and this is what actually people will use to say that this needs implementation. Okay, so when I do a class and I inherit this abc, make the class an abstract class, there I define an abstract method and I write this and I give these 3 dots here. That means this is a method that does not have implementation here and requires implementation in its subclasses. So you don't have to add that pass. Even if I run this, you can see the code still runs. Okay, so something that people will do if you're following coding standards, you can do something like implementation required, for example, and wherever people are implementing from here, they can just refer to this. When people are referring to this abstract class itself, they can just refer and say something like this. Now we talked about an base class. All of these classes are called subclasses since they inherit from the base class. Now why would you need an abstract class? And again, something that we told is there are some specific methods that you need to use, and those need to be implemented properly. Therefore, you have it as an abstract method. Now let me go ahead and tell you something else. So since this is an abstract class, right, that does not mean that it can only have abstract method. It can have non-abstract method also. For example, let's say something like who am I, for example, right, self, and this will say I am a vehicle. Okay, or I am a motor vehicle, for example, vehicle, and this is something that I want to inherit to my children. Okay, so this is, I'm not going to rewrite this functionality anywhere. Okay, so I will just do dot who am I, and similarly I'll do the same for a bike also. Okay, now you can see in both cases the functionality is still inherited. So just like how you'd inherit functionality from a class, you can inherit these also. The difference would be the where you have these abstract methods, you don't inherit them, you just have to implement them. So if you don't add this abstract method, you can see in the first case what happens is when this does not have the run method, it goes to the parent and inherits that method. In this case, that does not happen because it is an abstract method. It requires an implementation before any of this can be run. I hope you're clear with that. Actually, I'll give you another example also. Let's say I add this same thing as an abstract method. Now this will not matter at all because I can't access this once I put the abstract method, and both of these classes haven't implemented that method. Therefore I get a type error. Okay, here it only says car and not bike because Python follows an interpreter, but once this is there, it comes to this line, you can actually see that here also same error is happening. It cannot instantiate without this method. Okay, so that is where this is very important. Now let me go ahead and give you another more in detail, maybe very small in detail example on how this will be useful. Okay, so let's say I am going to create a class and I'm going to create a set of classes actually, and this will be like a food ordering system. Okay, and what happens when I order from ABC, import ABC comma abstract method, I can take this comma out. I am going to create my base class now, so that will be order base, for example. I'm going to call it that. And what will this happen? Okay, so I am going to define an abstract method, or before that let me just define a function called order. Okay, so what will this order do? That will do self dot place order. Okay, and then self dot get ingredients, and then self dot cook, and then self dot serve. Okay, and I have 4 functions, and that's how an order would work, right? So you place an order to a waiter, they will get the ingredients that's required for the cooking that the chef will handle, then the chef will cook, then they'll serve it back to you. Okay, so now this is the base order. Now this order, the process about how you place the order, you get the ingredients, cook and serve, depends on the product that you're ordering, the food that you're ordering, right? So all of these functions will depending on the case I have, right? So I can go ahead and create abstract methods for all of these. So place order and of self, this will be an abstract method. Similarly, abstract method get ingredients, for example, can be an abstract method, and an abstract method can again be define cook self. Now instead of putting this serve as an abstract method, we can actually make it a common method because all your food is going to be served only anyways. So just for the sake of adding this, I am going to do print your food has been served, hope you enjoy, something like that. Okay, so this is my base class. Now I am going to create my subclasses, and I'm going to create a subclass called pizza for now, order base. Now since I create this subclass, I have to implement all of the abstract methods first of all, right? So I will go ahead and implement the place order method first. And what will this place order do? It will do print pizza order is placed. Okay, next what do I have to implement? I have to implement the get ingredients, right? Those are the ingredients I get for pizza, right? And then I will go ahead and define the cook method also. So what will that do is this will be putting the pizza in an oven. Now once that is done, I can, yeah, my implementations are done because all 3 abstract methods are implemented, right? Similarly, I'll create a class called burrito, for example, right? So burrito, right? And this will be again implemented from order base. Here what I'll do, I'll place the order, and here I will just say print burrito order has been placed, right? And then I'm going to have to implement 2 other methods. So that'll be get ingredients, and there I will just say print. So first of all, I have to get a tortilla, right? So tortilla and then I have to getting veggies, the protein that you have in your burger, I mean, sorry, in your burrito, and then sour cream is something that you'll get, sour cream, and you can say something like packaging the burrito, and that's where they roll the burrito and all of that, right? And this is what this looks like. And maybe packaging the burrito would be part of the cook method actually, so I'll do cook self, and I can actually say print packaging the burrito, and print putting ingredients together. Maybe we can do that, putting ingredients, right? And my cook is also implemented, right? So I have two subclasses. Now what I'm going to do is I'm going to create instances of this subclass. Okay, so I'm going to create a pizza instance, so that will be an instance of pizza, right? Similarly, I'm going to go ahead and create a burrito instance, and that will be instance of a burrito. Now in the pizza, I'm going to go ahead and do the place order function, and similarly, sorry, not the place order, what's this called, order function, sorry. And similarly for the burrito, I'm going to go ahead and do the order function. Okay, and this will be the same thing. Now I'm going to run this code. I want you to see some things, right? So first of all, for pizza, right, which is our implementation of this abstract class, where we're rewriting these three functions, it says the getting pizza order is placed, getting cheese, getting tomatoes, getting doughs, putting the pizza in the oven, and cooking is the third function that we have, and then it says cooking, right? And similarly, the food has been served, which is a common function regarding here. So this is not something that we are implementing, it's common, and that's where inheriting that, so we get that also. Similarly for the burrito, the order is placed, that's the function that we're implementing. These three are the get ingredients function that we're implementing, and then these two are the cook function that we're implementing here, and this is the common function. Now something to keep in mind, that you can see that I know what the flow of my code is going to be like. So I'm putting one template, and regardless of what is going to be implemented there, I can say that regardless of what these functions say, the process for ordering would be, I will do the place order function, then I'll do the get ingredients, then I'll cook, then I'll serve. Okay, so these four functions, whether they have implementations or not, I can use them to in other functions, right? So this is very, very, very important, and I'll tell you why this is. Okay, so I'm going to have the place order function, right? It's not going to be an abstract method. I'll just do pass here. Okay, it is not an abstract method, therefore let's say the user forgets to do this, for example. Now explicitly I'm never calling this place order function, and I'm not defining also, therefore I think it's not needed. You can see that nothing happens here, right? Because this is just pass. And something to even, which is even more interesting, is instead of me having this function not at all, and I'm going to run this code again, you can see that it throws an error because the pizza object does not have an attribute called place order. I'm going to create a burrito object now and run this. You can see that it ran. Now here, this function does not exist in the parent class at all here, but it is inferred that I'm going to create this function in the subclass where I'm implementing this. So here I've implemented, but here the programmer has forgot to implement this function only. So what that simply means is, in cases like these where this confusion comes whether or not I have to implement something, you can just go ahead and add it as an abstract method, so that you can demand people to implement these methods. And once you demand people to implement, you can assume that these methods will be there. So in your other methods in your function, you can go ahead and use these methods to create your functions. Okay, so this is how template works. So now I'm doing this flow assuming that all of these will be implemented, and that is forced from my side using abstract methods. So in this video we talked about what a template is, why you need to use a template, what subclasses are, and what these base class is. We talked about what an abstract class is, what it has special to it, that are abstract methods. We saw that abstract methods are something that's enforced if you don't go ahead and do that, or at least implement that in your code. I hope this video helped you. If you guys have any questions about this template pattern or in design patterns in general, you can go ahead and put that in the comments. Other people in the comments, please help yourselves out, but I'll also try to answer these questions to the best of my ability. Thank you so much for watching this video. I hope this video helped you. I'll see you in another video. Until then, bye.